Okay, so section 3.3, this is the remainder and factor theorems. So first, the remainder theorem. The remainder theorem says if a polynomial, p of x, is divided by x minus c, then the remainder of that division is equivalent to the polynomial evaluated at c. So let's look at using the remainder theorem. So we are given a polynomial, p of x. We want to find the quotient and the remainder when that polynomial is divided by x plus 2. So we're going to use synthetic division. Looking at this, we have an x to the 5th term, x to the 4th, x to the 3rd. We have a 0, x squared, an x term, and a constant. So let's start with synthetic division. Okay, we're going to divide by x plus 2, so we have a minus 2 here. Okay, so bring down the 3. 3 times negative 2 is negative 6. Add those and we get negative 1. Negative 1 times negative 2 is positive 2. Add those and get negative 2. Negative 2 times negative 2 is 4. Add those and get 4. 4 times negative 2 is negative 8. Add those and get negative 1. And then negative 2 times negative 1 is positive 2. So I end up with a remainder of 5. So the quotient would be, this is our constant term, this is our x term, this is our x squared term, our x to the 3rd term, and we have 3x to the 4th. Okay, with a remainder of 5. So this is the quotient, this is the remainder, and then it says use the remainder theorem to evaluate p of negative 2. So we know that when we divide by x minus c, which in this case is x minus a negative 2, it's the remainder is equal to the polynomial evaluated at that c value, which means that p of negative 2, meaning if I took this polynomial, substituted negative 2 for x and evaluated it, I would get 5, because that is the remainder that we got here. Okay, so if I substituted negative 2 in for all of these values and simplified, I would get negative 5. Now here's the factor theorem. C is a 0 if and only if x minus c is a factor of the polynomial p of x, meaning x minus c divides evenly into the polynomial, then c is a 0. So let's look at this. We want to factor using the factor theorem. We want to show that p of 1 equals 0. Okay, so to show that this is a 0, we're really dividing by x minus 1. Okay, so we're going to just do synthetic division. My coefficients are 1, 0 for the x squared term, negative 7, and 6. And we're going to divide by 1. And if it divides evenly, that's going to show that 1 is a 0. So I'm going to bring down the 1. 1 times 1 is 1. Add those. 1 times 1 is 1. Add those. And then negative 6 times 1 is negative 6, meaning I have a remainder of 0. So because 1 divides evenly, this means that x minus 1 is a factor of the polynomial. Okay, so we've already divided by 1. So we know that we have x minus 1, and when we divide by x minus 1, this is our quotient. So I have x squared plus x minus 6, and we want to factor completely. this factors again. So p of x is equal to x minus 1 times plus 3 times x minus 2. Okay, so I want you to try this example using the factor theorem. So you want to show that x minus c is a factor of p of x, meaning that you want to divide by this and show that the remainder is 0. If the remainder is 0, that will mean that 1 is a factor.